All right. Hello, everybody. This is our ninth class of Paideia 301, Introductory Mumps. And we are going to be covering two topics today. And the topics we're covering are dollar order, and we're going to cover the do command. So we sort of made a foray last week into arrays, and I want to sort of finish it with just exploring dollar order. And your homework, so you could think about it, is very simple this time. Actually, it's an easy one. You're going to read the weight-in of 3 pumpkins. You have to print them. You have to print them out sorted. You have to print them out sorted. So while we're talking about today's class, you're gonna just have to think about how are we gonna sort the pumpkins by their weight. So, um, getting getting started, we are gonna talk about dollar order. Huh? No, not today. I'm not going over any homework today. Um, so today we're gonna talk about dollar order. So last week we had an array that looked like the following, and we talked about mumps arrays last week. So it had set x of 1 sub 1. I think somebody guys needs to mute. Somebody's banging something. So we had an array that looked like this last week in some way or form, and I did show you that we have a good debugging command. We have a command we use to debug. It's called zwrite, and it's used to print our local array. So if you do zwrite sub x in this case, it's going to print out your everything everything that has to do with x. So today's topic is about dollar order. So let me tell you about what dollar order is. So dollar order is, I think, is one of the most confusing commands in mumps, and it's hard to understand, and I'm gonna explain it to you. Then I'm gonna ask you to look at the diagram that I sent you, and then I'm gonna explain it again. So, dollar order essentially linearly traverses through a subscript level, or a branch level in mumps. So let me show you how this works. So if I write dollar order of, actually before I do that, just let me write it dollar order traverse. Okay, so write dollar order of x of 1. The answer is 3. Now you won't see much of a pattern here. Then we're going to write dollar order of x of 3. It's going to be 4. I'm going to write dollar order of x sub 4. And it's going to be, what's that? We don't know. It's strange. What's just happened? Okay. So this actually, we can identify it by doing this. We could say equal empty string, and it says it is equal to an empty string. So dollar order does give you an empty string sometimes. So we need to think about this some more. So let's try it again. We're gonna set so So who wants to tell me what dollar order of, excuse me, y sub 2 is going to be? Any guesses? Not quite. It actually is 8. It's 8. So it's going down the subscript. So let's do this again. So dollar order of is going to be 10. So you're actually, so if I do z right of y, I get excuse me, I get the subscripts 2, 8, and 10. So that's why dollar order is confusing. You could see that, you think it's supposed to get you the value, but it actually gets you the subscript, not the value. So let's do a more realistic example. So remember last week I showed you something like this. So now I would have thought that this would have worked, but it doesn't. Yeah, just I'm not sure.
Yeah, I was going to learn something.
Oh yeah, it's VA 200. That's why. Okay, so um, this expression is a sort of a is I would leave it to be an exercise for a student to figure out what it did. I'll tell you what it did actually. It printed the letters A through E. But this is just a debugging command that's only in GTM. That debugging command actually does not work on cache. So what you have to do is um, our exercise is actually in dollar order. So we're gonna start with write dollar order of up caret VA 200 comma B comma C. All right, so this will not be very clear on what's actually gonna get, but it's gonna get you Carlson Larry. So what we do with dollar order is, let's do it on some of the stuff that we could actually see on the screen. So I'm going to begin with the letter D actually, instead of C. So if you see D, you could see that it says, what I'm really telling it, get me the next subscript in that list that starts with the letter D. And it's going to say, okay, the thing that follows the letter D is Dalmol and Joseph. So I could tell it now after that is, okay, that's very good. Can you tell me what comes after Dalmol and Joseph? And you could see it's Deviler's Nancy. So now I'm going to ask it what comes after Robert Duane. Actually, oh, well, I missed one. I guess I answered the question, but here it is. I was going to say what comes after Deviler's Nancy, but it's actually Robert Duane. So what comes after Robert Duane? It's Dr. 8. And so on. That's how dollar order works. It just just goes down the tree. Does anybody have any questions about this so far? Okay, so what I want you guys to look at is we have a diagram that's titled mumps globals -2.png. If you could take a look at that, I'll give you a moment to bring it up. So if you look at that diagram, oh, okay, that's okay. Douglas says he forgot to fix it, except that Douglas doesn't. We're not teaching this thing that needs to be fixed in this class. Extra credit class assignment, all right? And I have to figure out what the extra credit is going to be. But your extra credit is to find the mistake in Douglas's diagram using the information in our last class. There is a tiny mistake, but the part I'm teaching you today has no problems with it. So if you look at the middle, about the middle of the diagram, you're going to find in pink something called dollar order, and I want you to look at that carefully. And it's essentially gives you an idea of how how dollar order works. Dollar order is a subscript traversal tool. So basically, it runs through a specific tree level and just keeps querying it for different values. And this is the thing that's important to remember. It actually just keeps walking through the tree, and if the value doesn't change, it just keeps it, and then if the value changes, it returns it to you. So um, in this case, we have a very tiny tree here, and in this case, if we do dollar order of PS sub 56 sub 0, it's going to be 1. So let's actually give this a quick try in the terminal. I'm going to do write dollar order of PS sub 56 sub 0, and it's 1. That's correct. Now, unfortunately, in this real file, it doesn't just have 1, it goes up to a big number. But eventually, after it reaches this big number, it reaches the letter B. Actually, it doesn't go to B right away. It does another letter. But I guess the diagram doesn't exactly correspond to the it only corresponds to the global structure that's inside the diagram. The important point is to know is that dollar order just actually moves down the list. And the other thing that we just haven't talked about yet, and we just want to introduce, is that dollar order can start with an empty string, which is the very first value in pink, and it ends with an empty string, which is the value in pink. So this is really important because guess what? When you're actually doing dollar orders in the database, you are going to be either starting from the empty string or starting from 0. Now, I won't talk about which is more important now. Today's our objective is just to understand dollar order, because guess what? Most of the MUMPS code that you write was going to involve dollar order some way or another. So let's look at our Y array again. And this time we're going to dollar order from beginning to end. Manohar, what I'm going to do is I'm going to explain it over again. Trust me, I know the dollar order is really, really difficult, and I'm going to illustrate it with the example here. I know dollar order is really difficult. I'm not kidding. It's so hard to understand, but I'm just gonna keep repeating myself, until it sinks in a little bit. So let's start with the empty string, because I did not. Okay. Oh, I made a mistake. Of course, I'll tell you what it is. Here you go. Tells you variable expected. So I have to tell it y, but I'm starting with the subscript that's the empty string. And you from that you get the number 2. So if you start, so let's take it back into here and run it again. Gets you 8. Run it again. Oh, I should write 8, not 10. Excuse me. That's so bad of me. Okay, so 8 gives us 10. And then 10 gives us nothing again. And is that nothing a space? It's not a space. It's actually an empty string. The only I could verify that by saying is this equal to the empty string? And the answer is yes, so it's an empty string. So so this is dollar order. Let me see. So we're gonna repeat our example again with X. But before I repeat it, Manohar, do you understand it a little bit better now? Okay, good, good. Okay, I'm gonna repeat my example again with X, and all I might, um, I'll see how much I want to torture you with repetition. I'm not decided yet. So you're gonna have to write in your Skype screen what the result is gonna be. So write X, write dollar order of X of an empty string. The subscript is an empty string. So what's the answer going to be? Okay. 1. Does anybody have any other ideas? 1. The answer, Tony. All right. Tom said Tony. Actually, Tom, it's not Tony. It's 1. Because dollar order traverses the subscript, it does not get you the value back. That's really important to understand. There is another function in MUMPS, believe it or not, that will get you the value back. It's not dollar query though. Like, oh, oh, I'm sorry. It's not dollar order though. I did give away what it is though. All right. So who wants to tell me what dollar x of 1 is, dollar order of x sub 1, x sub 1 is gonna be? All right, that's correct. It's 3. And 3. Okay. And what's x sub 4 gonna give us? Empty string. Exactly. That's right. Good job, guys. This is fantastic. All right, good. So here we go. We're gonna do a more complex exercise now. So our next exercise is we're gonna go back to Y, which we have the simple array, and the next thing I wanna show you is if I write dollar order of 5. Oh, of y sub 5. What's my answer going to be? Any guesses? Tom said 38, or did you just mean 8? You just meant 8. Okay. Okay, let's find out. It's just 8. Okay, good, good. I guess you guys are getting the hang of it now. And if I do dollar order of, oh no, you're I did finish typing. What's dollar order of y sub 1? Okay, all right, that's good. It's 2. Okay, very good, very good. I like that. Okay, so you do have a good idea of how dollar order works now. Now I'm going to make life a bit more miserable for you. Dollar order takes, remember when I taught you dollar extract and dollar piece and dollar ASCII? If you remember all of those functions, all of these functions took multiple parameters, and if they took multiple parameters, their behavior changes. So dollar order can take multiple parameters, and in its case, it only takes two parameters. It could and by and as with dollar extract and dollar piece and all of these other functions, if you don't supply the second parameter, it actually defaults to a default value. So let's talk about the second parameter. So when I give dollar order with the two parameter form, tells you the direction that you move. And I believe before the 1990 MUMPS standard that did not exist. So you might find very stupid code inside a FileMan that sorts stuff by inverse dates, which is a very strange thing to do. And you could say, why can't you just walk it backwards? The answer was, until 1990, you could not walk things backwards. So you'll find a lot of code in FileMan that's supposed to use dollar order with the reverse direction. So let's talk about dollar order with the second parameter that gives you the direction. So 1 is forward, -1 is backwards. So we're gonna try it again. So dollar order of y sub 2 going forward is, who wants to guess? Okay, good. So 8. Now, if I want y sub 8 going backwards, what's the answer gonna be? 2. So here you go. This is dollar order forward and backward. So the rule is, if you don't supply the second parameter to dollar order, then it means that you are moving forwards by default. If you need to move backwards, you need to supply the second parameter and make it -1. Now, and again, if you move back far enough with dollar order backwards, you actually hit the empty string. Okay, so I'm gonna show you something that we're not gonna talk about until maybe, I don't think it's next class, but the class after that, which is the for loop. But I'm gonna show you what we use dollar order for, because people are always wondering what this is nice. What do you use dollar order for in MUMPS? Well, a lot of your MUMPS code is about the traversal of arrays or traversal of strings, and so I'm going to show you a quick traversal of an array. So I'm just going to type. This is just an example. Don't try to fully understand it yet. So I better spell these out. Set dollar order VA 200I. Right. No, actually, we just need one. Just need one. Oh, it's no, the I is the looper variable. That's why I'm using the same variable. No, the set will only execute once. Set will execute once, then the for is gonna run after that. Okay, that's okay. That's okay. They're not. They promised me that they won't try to understand it. All right. Guess what did I just do, guys? I just went through the entire Vista new person file and printed all the users. Another example. Uh, I don't know what happened. Do I have my insert on? No, insert. Oh, okay, here we go. Here's another example, and in this case, I'm going through all the patients. Dollar order of DPT sub I, dollar piece of DPT sub I, comma 0, comma. Okay, and this I just went through all the patients. So essentially, I don't want you to understand the for loop. What I want you to understand is I just executed dollar order repeatedly, and I managed to walk through the global. So how are we actually? We're actually going to cover that in not next class, and I think next class is going to be about debugging, and we're gonna spend a lot more time giving you techniques to debug your MUMPS programs, which are becoming more and more complex. But the class after that, we're going to cover the for loops, and we're going to spend two classes on for loops. And this is sort of the typical for loop that you write to go through FileMan files and extract data from them. Okay, so that's dollar order, and I'm just gonna give you a hint for your homework. Remember, you're gonna weigh 3 pumpkins, and you have to print them out in sorted order. So here are your hints. Your hint number one is that remember when you put your data in subscripts, they auto sort. And hint number two is you can extract the auto sorted values using dollar order. And see, that should help you figure out how you would do your homework. Okay. So that's it for dollar order for today. The next thing we're gonna cover is the do command, and we're just gonna cover it. And we're sort of going to be using do a lot, and so you're gonna become much more familiar with do as we continue throughout the class. So let's get started with the do command. So you have no doubt seen already that do command where we actually we execute a routine directly with a do. So do runs a routine. And you guys, when you've been testing when you're testing your homeworks and doing other stuff, you've been running the do command. So simplest example is uh, Okay, so this one, for example, runs the routine di from the top. Um, but the twist to that, which is what you've been typically doing, is that you could actually invoke a specific label in a routine. So let's print the di routine quickly. All right. So if you remember from our second class, I believe it was, and we said that anything, here I'm moving the cursor, anything that does not start at the first line, at the first column, is a mumps line, and everything that starts at the first column is a label. So what I'm going to do now is, I like this label version. You see that there's a label called version, and I'm gonna actually run it. And then the next exercise I'm gonna do is I'm gonna run the label QQ. So let's try these. So we're gonna say do PDI, run the routine di using label p. So let's try this. So the example I'm going to give is do version up caret di, which is empty. Now I want to know, oh, it sets the variable version. It doesn't write it out. So let's write version, and it's right there. Very good. So if we do, I would do QQ up caret di, it just gives us that message. So this should be straightforward, and it's not very much different than what we have already learned. So what I'm gonna do now is actually, I'm gonna make a whole routine that contains all the different types of the do's. So let's get started. Um, I'm just gonna call it kband do. Oh, should be a good citizen and use VPE. So here's our first example. We are going to execute, for example, up caret di. And as I mentioned last class, it's when you're writing a program, it's a good idea to put a quit after you're done with your program. Otherwise, you'll have the situation which happened with Jignesser's program, where we just fell through and continued executing. Oh, sorry. Okay, so our next example of a do. So execute a routine from a label. And the example that I gave was do version up caret di. And this sets the variable version as we saw. So I'm just going to write version, new line, quit. Nope. Again, I should not do that. I'm a bad teacher. Here we go. All right. So these, I think the top and the label should be somewhat familiar to you right now because I think we've used them in the past. So before I move on with the other forms of the do command, I was wondering if anybody had any questions about these two. All right, looks like we're in good order, so we're gonna keep moving forward. So do has another form, and that is called do as label inside a inside a routine. So we'd call this internal. So for example, I'm gonna make a label called I1 and a label called I2. So I'm gonna say do I1 and then do I2. Now they don't exist right now, and here's the quit. I'm gonna say I1 first internal label. I'm gonna say write internal 1 new line. And don't forget the quit. Escape D. Okay, so that gives us the internal. So let's actually, you know what? Let's actually try to run the internal one. So let's give it a try. Okay, so that's good. So what? Okay, up. What about version, Manohar? Oh, okay. I'm not sure what you mean. Do version? Okay, I could do that. I can do just the label. Right, yes, I did not run that, so I'll go ahead and run it. I'll go ahead and run it. So I'm gonna do label upcard kband do, and here's your version number. All right, so here's the important part to understand. If you don't specify an up caret in the do name, actually, excuse me, guys. I might as well write this down. So if you don't specify an up caret in the routine name, it is assumed that you are calling an internal label. Now we don't have Ted Stanger today with us, but he's the one who was complaining about all those go-tos. And he's absolutely right. You should not use go-tos. You should use do commands instead. And remember, we used a lot of go-to labels in our code. Well, that that now this is something now I need to get you in the habit of not doing. You've used enough go-tos for your entire career. So what you have to do now is you need to run with the do command. And every time you run the do command, what you do is you execute something like this, and then you quit. So, um, one question that it's something that I actually need to show you now rather than later. Um, I've been talking with Douglas here about how to introduce the stack, and I might introduce it just a little bit right now, and I want to show you very quickly what the stack looks like. And for now, I'm just gonna write a variable called $stack here, and write $stack. And we're gonna do it here too. So, and we are actually, since this is stack sensitive, we cannot run it exactly $stack in the top one. Oh, sure, I can do that. I don't mind. Yeah, that's right. Thank you. I left out the dollar. Thank you. Here we go. I did leave out the dollar. Thank you. That's very good. Okay. So, my honored guest tells me that I need to add the identifier. So he's absolutely right. So stack before do, stack after do. Actually, now let's make this 1. Make this 2. Okay. Oh, I didn't change it. My God. Today is not my day. I'm gonna actually do an I3 as well. Oh, and don't forget to quit. Okay, but here's the twist now. I'm gonna call I3 from within I2. Here we are. So now I guess we could go ahead and save it and run it. So do internal of kband do. Okay, this is the wrong answer. So that's why I said I don't have to do it from VPE, because that's gonna confuse you. All right, let's run this in here. Okay, very good. This is the answer we are actually expecting. So we really have to look carefully at how this actually worked, because this is really confusing. Internal plus 99. We want the whole thing. So I'm going to move my cursor so we can try to follow along. So if you notice, you look when we in a typical do block in mumps. Uh, well, um, I'm trying to explain that. The stack, I can't explain totally today, just today, what the stack is because it's really a computer science concept and I'm still trying to figure out how I'm going to teach it. But what's important for you to know today is that it's think of it as a control structure, and essentially computers use it to track which level you're on and which data structures you have, and your data structures could vary by level. And we're not going to talk about this today so much, but I just want you to know that do actually increments the stack, whereas goto does not. And we should do an example with goto to no, okay. No shouldn't mention ever never be used. That's right. Okay, goto banish goto. So um, when you start with when you start running a mumps program, your dollar stack. Okay, we're getting to it. We're getting to it, Jignesh. We're gonna get to it. Uh, when we start running our routine, our stack is always going to be one. So if you look at this line up here, it says stack before do is one, and when we go down here, the stack before do is one. So when we do I1, what happens is the stack level increases by one. So when we hit this dollar stack over here, our stack should be two. Is it two for internal one? Yes, looks like it is. Okay, good. So, but guess what happens when we hit the quit? When we hit the quit, it takes off a level of the stack. So we are back down to stack level 1. Then we run this, I2. And again, 1 plus another 1 is 2. So stack after do 2 should be 2. Let's check. Yes, it's 2. Jignesh, does that answer your question? So why would do 1 be 2? Let's see. Do you mean do I1 is 2? Okay. Because the first level of the stack is 1. So when we call something, the second level of the stack is going to be 2. Okay. All right. So the quit takes off a level of the stack. So when we are down here again between the I1 and the I2, we're at stack level 1 again. And then when I go to I2, it adds another level to the stack and it becomes 2 again. Oh, okay, good. All right, fantastic. Okay, why did VPE give us a different result? Well, VPE is a programmer. It's a MUMPS environment that EXIC emulates a programmer shell, and when you're running a programmer shell, we're actually running a MUMPS routine inside of MUMPS. So we are already up the stack a little bit because we have been somebody did us already and we are we are doing other things on top of that. That's why we are on top of we have a different result. Okay, good. All right. So remember, at this point, we are 2. So when we do I3, what happens is we did not hit a quit yet, so we're still at 2. So when we do I3, our dollar stack here is 3. And then we hit a quit. Then we go down to stack level 2. Then we hit a quit. Then we go back down to stack level 1. And so if I wrote dollar stack after this line, it's going to be 1 as well. So let me ask, does anybody have any questions about this? Knowing that we are actually going to cover this a lot more in the future. So if you sort of get it, that's good enough. Okay, just for curiosity, what's the question just for curiosity? Okay, Jignesh, have you ever looked at a Vista error trap? You'll figure out what's the usage of the stack right away. Or actually, for that matter, if you ever run a Java or a C program and you have a backtrace, that's also a stack representation. It's the same concept. So the stack essentially helps programmers write and debug code. That's its primary goal. That basically, in C, in Java, or even in MUMPS, it just puts code on different levels and enables you to figure out how to run it, how to uh, its main purpose is to debug your code and organize your code. In the C language, it has more uses because it actually organizes how you actually push arguments onto the stack and pop them off the stack. Okay, good. That's good. I mean, this is good enough. The stack is really hard to understand, so I'm sort of introducing you to it bit by bit. So that's good. That's good. So, um, we are not done with do. We still have another form of do. So let's work on it. So let's see. Let's go back to VPE. Oops. Okay, so we have something called the anonymous do, and that also was introduced in the 1990 MUMP standard. So if you see a lot of older code in Vista that doesn't use it and looks very odd, like how the hell don't you use it? That's the reason. So what the anonymous do is the equivalent of blocks in C style languages. So an example, do you put a dot, so you cannot do a left brace and a right brace in MUMPS. You have to do a dot, and this is where we get to what we call dot levels. So okay, this is the very simplest example I could have picked up. Dot quit? No, actually, I don't need. Oh, that's right. Okay. Kurt makes a good point about why don't I have a dot quit, and this is something I need to explain. This is a good point. Let's actually put it there for the first time. So we're gonna keep it there because a lot of experienced mumps programmers put dot quit, but it's not exactly needed. We're so let's go ahead and run it. And so do anon up caret k band do. All right. So I guess let's print the program and just make sure, that this it did what we wanted it to do. Anon plus 99. So there's nothing fancy here. And, we're, it's doing nothing fancy, and it's almost useless. So what do we use this for? Well, we use this for um, executing a block of code for if commands, else commands, and for loops. That's its main use. And it also has an extra use which is advanced enough that I don't want to tell you about it today. So we're just gonna go back, and we're gonna say we're gonna type read how are you question mark. We're gonna say if oh well, I need to put it in a variable, don't I? Read into x how are you. If x equals the letters fine, do. All right, so here's the magic. So it's gonna actually execute code now. Wrong key. Okay, so we're gonna say do. I'm glad to hear that. And then we could do else and a do. We're gonna come back to this quit. I'll put it there too. Dot quit. What's wrong? Is it your mom? Oh, well, I keep pressing on the end key when I main, I don't want that. Okay. Oh. Okay, so let's actually run this and see what happens. Let me print it out first. So here we go. So do anon upcard k band do, and it's asking how are you, and I'm gonna tell it I'm fine. All right, yes, I need to put a new line after that and spaces and whatnot. But we get what we end up with. It executes the if block. You see that, and the else block is not executed. So let's run it again. And here you are. It executes the else block. So essentially, having a do block enables you to have what you would call anonymous blocks or anonymous labels. So you don't have to pull out all of that stuff into a label and execute it separately. You can actually just run it just like that inside of the routine. So let's actually try that for a change. So we're gonna do a little refactoring, and if I remember correctly, I think to select something is escape M, I believe. Nope, it's not. I always have to. Oh, it's F3. Sorry, F3. Here we go. Oh no! We're using an old version of GTM. That's what the problem is. Yuck, sorry guys. Technical problems. So I just copied that. So I'm gonna create a non-one for and then I'm gonna paste. So escape V should paste. Should paste. Oh, maybe I need to tab escape V. Here we go, it did paste it. So go ahead and delete these and remove this line. Escape D to delete the line. And so I can do a non one. Escape, escape, save. So let's go ahead and print it again. Here we are. So again, same idea, and the big difference from last time is the following. You see that the if block up here, the do runs what we call an anonymous block, and you could see that it runs through this code and it's done, and then it goes back. And then the else, instead of running an anonymous block like we used to before, it does this, do anon one, and it just runs down here. Anon one, this, and this, and it's done. And then it runs back. Let's run it. The dot, is it only used with the do command or any block? No, it's all in MUMPS. Only the do command can create blocks that are essentially continuations of the if, else, or for commands, or just by itself. You could just do a do block by itself, but you have to have a do. There's no such thing as an empty block. Actually, I'm going to show you an example. It's a good thing that you ask. Can you run any block when it doesn't have a do? We'll try that. So anyways, let's run this. I'm going to say fine, and I'm going to say not fine, and I get that. So let's address Jignesh's excellent questions of can you create, like, you can, so for example in C you can actually create blocks which are just there for containment. They don't actually matter. They're actually stacked. They're actually not stacked, are they? Their variables are protected, however C does it. But my Jignesh's question is a good one. Let's make something that we're gonna call can anon. can this be anonymous? So, oh, whoops, I did this again. Actually, let me just do this. In block, and then, nah, I'm not used to this. I always use the end command. Quit, right, out of block. Okay, so do, can, anon, kban do. Okay. So Jignesh, do you want to tell me what just happened? Exactly, no do. So if there is no do, the block is never going to get executed. So it got skipped. That's exactly right. That's exactly right. So that's and you know one of the some of the nastiest bugs you're gonna make when you're writing mumps code are going to be when you have entire blocks going on forever and then you forget one of the dots, and when you forget a dot, it's all over. Yes, Douglas. Yes, it's gonna ignore those lines. It's not. Uh, some Yeah, it's depending on how the mumps implementation and where you actually call your do block. It sometimes will give you an error and tell you that you are not at the right level. I've seen that error before, but I don't remember exactly where it happens. Yeah, it's. I thought it would give you an error, but there is no. There's nothing like that. Maybe it's VPE that's is trapping the error. I think I would have caught it, but I'll try it. Um, so Jignesh is asking, is there anything called object-oriented mumps? So don't worry for blocks. No worry for blocks. This we're gonna. Uh, there's Object oriented mumps is the pet project of many people, but at this point in time, object oriented mumps doesn't exist. What there's a framework called ESI objects, or we call it easy objects. That is object oriented mumps. But what the way it works is you write mumps code and it eventually compiles down into mumps. Okay, so back to our routine, and now I want to get back to Kurt's point about putting quits at the end of dotted blocks or anonymous blocks. So whenever you hit the end of a dotted block, you execute a quit automatically. That's implicit in the language. Even though it's implicit in the language, a whole bunch of mumps programmers still put their quit. It's sort of a religious issue in the mumps community. It's not that? You don't think so? You don't do it. Okay, but it's fine. You don't do it, but I know Chris Richardson sure as hell does it all the time. I mean, I I understand. There are not just him. There are several other people who do it too. Just I don't know why you do it. Why some people do it, but maybe they want the mumps code to be clear to say I'm quitting here. Yeah, that's true. That's true. But the do block. If we remove this quit here, so let's go ahead and delete this one and delete this one. We're gonna just get the same execution. So there's nothing that's going to be any different because it's just a visual separation. Exactly. So um, that's uh, that's that. So actually, let's run it again. So we're gonna do run anon. Oh, I don't know what it did here. Okay, here we go. So z print kban anon upcard kban do to anon plus 99. So print the whole thing. So do anon. All right. So this is what's gonna tell me. So the behavior hasn't changed. So, okay, here's now I'm gonna blow your guys' minds. There's something that's really, really annoying about moms, and it confused me so many, 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 many times. Okay, so if you have a do with two spaces after it, it is going to descend. It's going to look for an anonymous block or a dotted block, however you want to call it. And then when it's done, it hits the implicit quit. What do you think happens after that? Where do you think it continues? This is the hard thing, and it really confuses me. But what really happens is that when you hit down here, mumps goes back to the do and continues with the line until it's done. And guess what? You could have yet another do on the same line and it will execute the line again. But we're not going to do that. So I'm going to illustrate it that it actually does that. So let's go ahead and save it. All right. So again, this is important. I'm going to repeat it because it's going to cause you a lot of heartache in your mom's programming careers. The do descends into the block once invoked, and it has two spaces. Now remember, a do with one space and a command. Let's say that there weren't two spaces here, and there was only one space. It's going to execute write as a label. So it's going to look for a label called write. But do with two spaces means I have an anonymous block coming up, and I'm going to execute the block. Then when I'm done with the block, I hit an implicit quit, which we can't see. Then it goes back up and runs this code. Yes, exactly. It's not perfectly logical to any people. So Kurt is telling me that it's perfectly logical, but I'm gonna counter that. It's not perfectly logical for a lot of people from other languages. The expectations that once you go into a block, you're actually going to continue down after you're done with the block, not go back up. That's where it's confusing. All right. Okay. So some this here it's just not good programming practice, but what some people do is but what some people do is the following. Let's give it a good use. So what I'm gonna do. So Jignesh asking is in two spaces. First space is anonymous block. No, no Jignesh. Yeah, okay. The way Kurt explained it is that it's a null label for what you're executing, and it instructs mumps to go down a level and starts looking for dotted lines. If it can't find dotted lines, it's supposed to give you an error, and I'm willing to try that. I want to see if it actually works. Oh, yeah. This is not my routine. Here we go. Going back to anonymous do. So okay, I'm gonna comment these line out. So I'm gonna put a semicolon. Now they don't exist anymore. Uh, and we need more lines. Okay, so do anon. Okay, keep and do. Okay. I would have thought it would have given an error, to be honest. I'm not sure why. There's no dot block, and so it just quits. Okay, maybe that's the way it works then. That's right. Well, this is the big gotcha. Okay, this is a big gotcha. So we're gonna do this. So we're going to Jignesh, I'll come to that question in a moment. We're going to do this. We're gonna make a first dotted line. The second dotted line is commented out because I'm gonna say nice comment here. I'm gonna say right. Have a good day. All right, let's print it again. I should find that back in my history now. I have to typing again. All right, so okay, you here's this happened to me like a million times writing mumps code. I've done this so many times. I'm intending to put a comment and I forget to put the dot before the comment. So guess what? When mumps sees one dot and then zero dots, it means okay, I've hit a quit, no more do. And then I hit the next line, and the next line does not have a do in front of it, and so it never executes or do above it, and so it just goes down here and continues. Happened many a time. I'm very glad to say it's gonna happen to you too. So, um, now Jignesh's question was, what if there's a single space after the do? If there's a single space after the do, like this, so I'm gonna move my cursor. This has a single space after the do. This will execute the label anon. So if there's a single space after the do, it's gonna assume that the next thing that you're executing is a label. Oh, oh, okay. Okay, good. Take the space out where? Oh yeah, sure, absolutely. That's a great idea. Hmm. So we're gonna remove the space. So now we only have a single space. Oh, now GTM will refuse to compile it because it's gonna say label reference but not defined, right? Because it thinks that's right to the label. It could be, but it isn't there. Okay, well, it's 5:30. We're almost done. So today's homework is, and I'm gonna type it. Ask the user to weigh 3 pumpkins at the Halloween festival. Sort the pump by weight, highest first, and print them out. That's it. This homework in difficulty is actually, using a dollar order. It's going to be actually easy. So I would say, that this homework shouldn't take you that long to do. So that's it for today's class, and I am going to send you the notes. I hopefully could catch them, and I got the notes for last class too, so I'll be sending those for you too as well. So that's it. Have a good day.